Welcome to part 3 of 5 of the 2018 Storm Spotter training from the National Weather Service in Milwaukee. I'm meteorologist Ben Herzog and I'll be guiding you through this course. In this section we'll talk about deploying for severe weather spotting. When we talk about deploying, we're talking about going out and actually looking for the storms. A key question here is when and where should you go out to look for and report on storms? The types of things we're expecting you to report back to us are hail and damaging winds. In general, you can just let us know what's going on at your location. You can report the hail size and wind speeds and damage as soon as the storm ends. We're also looking for reports of flooding and heavy rain. Again, just measure this at your location. You don't need to go out and looking for a very heavy rain or washed out road, things like that. Finally, tornadoes. Generally, if you stay at your location, you're probably not going to see very many tornadoes. The odds of seeing the tornadoes goes much higher as you go out looking for them. So the following slides will apply to going out and looking for tornadoes in these tornado situations. So, when should mobile spotters deploy on storms? Do you go out when a watch is issued? Well, take for example the image here in the top left portion of the screen. You can see a watch is issued for most of central and southern Wisconsin, and let's say for example that you're sitting in Madison as this watch is issued. In all likelihood, you've got several hours before these storms come down to your area, and you could be looking at something like what you see on the top right. Heck, you might even get sunburn while you're waiting for these storms to come down. So if you go right when the watch is issued, that's probably too early. Do you wait until the warning is issued, like we're showing in the bottom left here? Well, if you do that, then it's probably too late. That means the storm is on your doorstep and you're really not going to be able to put yourself in a good position to spot. Instead, we suggest that people self-activate. The National Weather Service does not activate spotters, so you're kind of relying on yourself to know when to go out there. In general, you want to stay ahead of the storms and monitor conditions and warnings in nearby counties. A great way to do that is monitoring radar trends like we're showing here. Make sure you're proactive. Get out there before the storm gets to your location. And keep in mind, as you go out there, you may not see anything. Tornadoes are inherently very rare, and that's okay if you don't see it when you go out there. When it comes to spotting locations, again, you may be stationary or mobile, but again, here we're talking about mobile spotting. In general, it's a good idea to be upstream from your city. For an example, let's talk about Madison again. Let's say that you position yourself 5 miles to the west of Madison, knowing that storms are coming from the west. That means you're upstream of the city, and that means you're going to see the tornadoes before they move into town. Contrast that with if you position yourself 5 miles to the east of Madison. Then, as you're looking to the west, the storm's coming your way, and you see the tornado come down, you may well be looking at the tornado hitting Madison. While we're happy to get any reports of tornadoes that we can, in general we're much better off if we can get the reports before they make it to a large population center, and our warnings can affect as large of a group of people as possible. In general, when you're spotting, you want to make sure you have good visibility, so position yourself on high ground, try to avoid trees, don't let any buildings obscure your view, and make sure you know your escape route. Know how long it takes to get to shelter. Make sure you've got multiple ways to get away from where you're at in case something crazy happens. I mentioned radar earlier, and keep in mind, radar is your friend. What we see here in the top left portion of the screen is what the inside portion of the radar at National Weather Service Milwaukee looks like, and the large golf ball looking structure in the bottom left is actually the outside view of the radar. The way our radar works is it spins around and around in circles over and over, gradually tilting higher and higher into the sky, and eventually it allows us to paint a picture of what's going on in the atmosphere across southern Wisconsin. We strongly recommend that you download a good app that shows your location relative to storms, so it'll plot a little pinpoint on the map where you are, and then you can get an idea of how your position relates to where the storms are at. A little bit more information about how the radar works. The radar product you're probably most familiar with is called Reflectivity, and basically the way that works is the radar emits a very short pulse of energy like you're seeing in the large image here. That pulse of energy goes out into the atmosphere and eventually it starts bouncing off of things, in this case raindrops. The more raindrops it bounces off of, the more energy is reflected back toward the radar, and that's how we get the name reflectivity. So in the image in the top right where you start to see the yellows and oranges and reds, that means that our small pulse of energy is bouncing off a lot of these raindrops and maybe some hailstones and maybe some other things, and that energy is getting reflected back to the radar. So again, the more you see here, the brighter it's going to be. Here's a look at another radar product you may be familiar with called velocity. In these images, anything in red is air moving away from the radar, and anything in green is air moving toward the radar. The brighter the colors, the faster the speeds. So in this example, we've got some bright reds right next to some bright greens, which shows air moving very quickly away from the radar right next to air moving very quickly toward the radar, and from this signature we can infer rotation. Now keep in mind, just because a storm has rotation does not necessarily mean it will be tornadic. In fact, a great many of storms that occur actually do have some broad rotation, but they never go on to produce a tornado. Now, you're out there looking at storms and you're trying to figure out how to best position yourself relative to the storm. For this example, we'll take a very generic form of what's called a supercell thunderstorm and use that as a great way to understand how to position yourself. Do you put yourself in the northeastern portion of the storm? Well, that's probably not going to be the best idea because you're going to have to look through some very heavy rain to see where the tornadic location is at. How about the northwest side of the storm? Well, it's kind of the same deal. You're looking through a lot of very heavy rain, maybe some hail, and that's really going to obscure your view of the tornado. How about to the west? You may be a little bit better off there because the rain is going to be much less heavy, but in all likelihood you're still not going to be able to see anything because you do have to look through all of that precipitation. Ideally, you want to try to position yourself to the southeastern portion of the tornado so you don't have any precipitation blocking your view to the tornado. You also don't want to position yourself too close to the tornado and have a Homer Simpson moment as that tornado comes to your location. So here's a couple of examples of radar versus reality. The white pinpoint that you see on the radar image is the location at which these pictures were taken. Notice how the pictures were all to the southeast portion of the storms, and they're getting very good view of something that's called a wall cloud, which may be a precursor to tornado development. So going back to the Chetek tornado that we spoke about earlier, this tornado was on the ground for nearly 80 miles. However, despite being on the ground for that long, very few pictures exist of this tornado. Now how can that be? How can in this day and age of smartphones can there be almost no pictures of this tornado that was on the ground for several hours? Well, a couple of things came into play here. If you're at all familiar with the area around Chetek, the terrain is quite hilly, there's a lot of trees, that makes seeing things difficult. Additionally, the road network is not very good for going out and looking at tornadoes. But most importantly, look at the radar imagery here. You can see where the tornado was located, and look to the south and to east of there. You see a lot of precipitation on the radar, and unfortunately that just made it really hard for spotters to get close enough to actually see anything. In the top right portion of the screen, we got a picture from someone looking right at where the tornado was at, and all you can really see is rain coming down from the clouds. Here are a couple of tornadoes that we had in southeastern Wisconsin last June. These were two EF1 tornadoes near Monticello. However, these storms are on something that we call a squall line, and squall lines are typically very difficult to see tornadoes on. In general, we don't have any expectations that you're going to be able to see tornadoes on a squall line, and here's a good example why. It just looks very messy. The other problem with squall lines is they can be somewhat unpredictable. Here's what that storm looked like on radar, and the person taking the picture was right in this location. They were looking to the southeast, seeing that tornado that was going to their south. Unfortunately, they had no idea that there was another tornado back to their northwest heading directly toward them. So this is another example why trying to spot tornadoes on squall lines is generally not a good idea. They can put you in some dangerous positions if you're not being careful. So that brings us to the end of the deploy section of the storm spotting process, and up next we'll go into observing. What is it that we're hoping that you can see for us?